Hi everyone, Hina Wajid here. So today we are going to make SPI formulas. Very simple, and we will quickly revise for the exam. So let's start. First one is speed of sound. So speed of sound C is equal to F multiply lambda. Frequency multiply lambda. This is also known as wave equation. Then if we want to calculate wavelength from the wave equation, it's very easy. Lambda is equal to C by F. If we want to calculate frequency, that's frequency is equal to C by lambda. Now period known as T. So period and frequency are inversely related. T is equal to 1 by F, F is equal to 1 by T. Next, pulse duration. Pulse duration is actually the sound on time. That is, number of cycles multiply time period. And we know period and frequency inversely related. So we can write it as pulse duration is equal to number of cycles divided by frequency. Multiply by period. If we want to write frequency instead of period, that will be 1 by F. So number of cycles divided by F. Next there is SPL. SPL is special pulse length. That is equal to number of cycles multiply wavelength. Okay, axial resolution. Axial resolution is SPL divided by 2. Okay, then there is PRP. Pulse repetition period. So pulse repetition period and pulse repetition frequency, they are inversely related to each other. So if, for example, pulse repetition frequency is 10, what about pulse repetition period? It's 1 by 10. Its answer will be 0.1. PRF, pulse repetition frequency and depth relationship. PRF is equal to 77,000 divided by depth in centimeter. So, increased depth means PRF decrease. And less depth, shallow depth mean PRF increase. Then, go return time value is fixed. 13 microsecond per centimeter. And if we want to calculate the total time, then its depth multiply 13. Okay, so if depth is 10 centimeter, total time will be 13 multiplied 10, 130 microsecond. If the depth is 20 centimeter, total time will be 13 multiplied 20, 260 microsecond. Then there is duty factor. So duty factor is actually on time divided by total time. So on time is pulse duration and total time is pulse repetition period. Pulse repetition period involves the time pulse takes to travel, reach to the structure and also to come back. What is TI? Thermal index. It measures heating risk. It should be less than 1. And when TI increases, follow a LARA. As low as reasonably achievable. Exposure should be reduced. Time duration should be reduced. Okay. Intensity and power and amplitude relationship very important. What is intensity? It is power by area. So when area is less, increase intensity. So in focal zone, there is small area, so intensity increases. Intensity is directly proportional to amplitude square. Power directly proportional to amplitude square. If amplitude increases 5 times, intensity increases 25 times. And if amplitude increase 2 times, power increase 4 times. Very important. Intensity directly proportional to amplitude square. Power directly proportional to amplitude square. And intensity and power, they are directly related to each other. Some important points. In soft tissue, speed of sound is constant, that is 1540 meter per second or 1.54 millimeter per microsecond, that is known as calibration speed. So ultrasound machine assumes speed is always constant, but that's not always true. That's machine assumption, that is not always true. So when a tissue has speed of sound less than speed of sound, for example fat. So fat has slow. So fat has low speed of sound as compared to the soft tissue. So fat echoes will take more time to return back and to reach to the transducer. So its echo will displayed deeper than original location because it don't follow machine assumption. So machine displayed fat echoes at a wrong location. In muscles, speed of sound is more than speed of sound in soft tissues. From muscles, echoes reach very fast, so they are displayed superficial as compared to their original location. That is a speed error artifact, very important concept. Fat echoes displayed deeper because speed is less. Muscles echoes displayed superficial because speed of sound is more as compared to soft tissue. Higher frequency have smaller wavelength and lower frequency have more wavelength. Now resolution and penetration relationship with the frequency, very very important. Higher frequency means good resolution but poor penetration. Also attenuation and frequency relationship. Higher frequency means more attenuation and Rayleigh scattering and frequency relationship is also very important. When frequency increases 2 times, Rayleigh scatter increase 16 times because Rayleigh scatter directly proportional to frequency power 4. So when there are more number of cycles mean longer pulses, longer on time. So pulse duration is number of cycles multiply time period. Increase number of cycles, it means pulse duration is more, longer pulses. What is the duty factor? Duty factor is on time divided by total time. In CW, it's always on, always transmitting. So duty factor is either 100% or 1. Pulse wave Doppler. Duty factor is actually very less because on time is 1 by 1000. If total time is 1000, on time is 1. So duty factor in pulse wave is almost 0.001 or 0.1%. That is very small. In CW, it's 100% or 1. And thermal index, so it should be less than 1. If it is more than 1, be cautious. Follow LRR principle.